The Moon, not as geologically dead as previously believed for decades. Scientists believe the Moon was a geologically inactive, or dead, body, having ceased any significant geological activity billions of years ago. This idea was based on the apparent lack of large-scale volcanic activity or tectonic movement on the lunar surface. However, new research and observations have challenged this assumption, suggesting that the Moon might still be harboring some surprising geological activity. The shift in understanding in recent years, evidence has emerged that suggests the Moon could still be experiencing minor geological processes, albeit on a much smaller scale than those seen on Earth. Seismic data from past lunar missions, especially from NASA's Apollo program and more recent lunar orbiters, have provided intriguing clues about the Moon's interior. Scientists have detected small moonquakes, some of which appear to originate deep beneath the lunar surface. These quakes are believed to be linked to lunar tectonics or the slow cooling of the Moon's interior, indicating that the Moon's internal structure may still be active in some ways. These seismic activities are not the result of volcanic eruptions as on Earth, but they do suggest that there may be some form of ongoing tectonic or thermal activity beneath the surface. Lunar volcanism, a thing of the past. While there is no active volcanic activity on the Moon today, scientists have discovered evidence of past volcanic events that have left their mark on the lunar surface. The Moon's volcanic history, which peaked around 3 billion years ago, is characterized by the eruption of lava that created vast plains of basalt known as maria. These volcanic regions are relatively young by lunar standards, and their formation shows that the Moon was once more geologically dynamic than it is today. Additionally, research using data from orbiters like NASA's Lunar Reconnaissance Orbiter and China's Chang'e missions has uncovered evidence of what might be volcanic vents that appear to be relatively recent in geological terms. These findings have raised questions about whether the Moon could have experienced minor volcanic activity after the period of peak volcanism, possibly indicating that the Moon's interior wasn't entirely inactive. The mystery of the Moon's mantle. One of the most puzzling aspects of the Moon's geology is its mantle, the layer of rock beneath the surface. Researchers have found that the Moon's mantle might still be partially molten, which could be responsible for the weak seismic signals observed. This is in contrast to previous models, which suggested that the Moon's interior had long since cooled and solidified. If parts of the mantle remain molten, this could explain some of the ongoing seismic activity. Implications for future exploration. Understanding the Moon's geological activity has important implications for future exploration, particularly in the context of establishing lunar bases. If the Moon is still geologically active, even to a small extent, it could affect the stability of structures built on its surface. Additionally, future missions to the Moon, such as NASA's Artemis program, may need to account for the possibility of seismic events or minor volcanic activity in their planning. Furthermore, investigating the Moon's interior and its ongoing processes could offer valuable insights into the early history of the solar system. The Moon is considered a time capsule, preserving clues about planetary formation and the processes that shaped not only the Moon, but also Earth and other planetary bodies. The Moon is far from geologically dead. While it might not have the active plate tectonics or volcanism of Earth, there is growing evidence that suggests the Moon's interior is still undergoing some degree of activity. As new missions continue to explore the Moon and gather data, scientists are likely to uncover even more surprising details about the lunar surface and what lies beneath. The Moon, it turns out, is more dynamic than we ever imagined. The role of the lunar South Pole. One area of particular interest to scientists is the lunar South Pole, which has become a focal point for exploration due to its unique characteristics. Unlike the Moon's equatorial regions, the South Pole is believed to harbor water ice in permanently shadowed craters, which could be key for sustaining future lunar missions. The geology of this region could offer further insights into the Moon's geological past. In addition to the water ice, the South Pole may also hold clues about the Moon's geological activity. Some researchers believe that the region might be tectonically active, potentially linked to the moon's internal structure. Seismic data gathered from the region could reveal whether minor tremors or moonquakes in this area are related to shifts in the lunar crust or even volcanic activity beneath the surface. A window into the early solar system, the moon's preserved surface is one of the best records of the early solar system's history. By studying the mineral composition of lunar rocks and soil, scientists can learn about the processes that shaped not just the moon, but also the Earth and other planets. The lack of an atmosphere and plate tectonics means that the moon's surface hasn't undergone significant erosion or recycling, making it a time capsule that retains features dating back billions of years. As part of this ongoing research, scientists are particularly focused on studying the moon's impact craters. These craters serve as a reminder of the constant bombardment the moon experienced during its early history.